this prompt injection if you like. There's another one below this one called Doublespeak, and this one sets up a sort of role-playing game where you're a detective, and you can in fact play the game to find the secrets, although I never did that. It's more fun to hack the game and trick it into coughing up the secrets. Both techniques work. So you can do more of that if you like, and that's good, but let's talk about some other things here. Now, probably much more productive is generating code with Bard, and Google announced about a month ago that they had upgraded Bard to where it gets good at generating code and running the code. So let me get my Bard up, and let me try this. I'll give that again, thank you. All right, so if you give it a simple command, like write Python code to count from 1 to 10 and run it, then it will do this for you. Sort of, as we're going to see. Okay, here's the Python code, and that code looks pretty good, and you can run it. Here's the output. By the way, be warned, it's lying. It does not run the code to create the output. It is claiming what the output ought to be with complete disregard for whether the code will actually do that. You have to understand everything about LLMs. They lie all the time. They don't know what they're saying. They're just making it look good. So you can run the code, though, down here. There's a button to just send it up to Bard. Export to Colab. Colab we're going to use for a lot of this workshop, although it is not opening Colab, which is strange and disturbing. Export to Colab. It should. New Colab, oh, it's going to save the new Colab notebook in my drive. I have to go down here. Something went wrong. Neat. Well, maybe that's automatic exporting is not going to work. If it doesn't, you can open Colab, colab.research.google.com, and make your own new notebook. This is a great Python environment, not very powerful, and you can't beat the price. And so I can put in the code that Bard created. This is what I used to have to do before Bard's new celebrated thing where it would automatically load it, which doesn't seem to be working, but there's always something. So if you put the code in Bard and run it, it ought to work. There it is. It works. It counts from 1 to 10. So it can solve a problem like that. But if you give it a more difficult problem, like this. I want to generate the first 10 prime numbers, but include only every other result and multiply them together. And I told it to put out a lot of things about it, because it turns out that it gets everything wrong, and I actually have to fix the code. So telling it to put out various related things helps me understand what the problem is. So there it goes. Generate the first 10 prime numbers. Right there is beyond Bard's capability, or at least it was when I wrote this a couple weeks ago. And okay, here's the Python code to generate the first 10 prime numbers. Ooh. Yeah, here we go. For 2 to n plus 1. This is much more complicated than what it was producing a week or two ago, and it might even work. Before, it would only, no, I think not. Generate primes 10. Generate primes will generate, this looks like this might work. This is greatly improved. Before, when I told it to find the first 10 prime numbers, it would just find the prime numbers below 10. And it could not understand that it had to actually produce 10 outputs, but in the documentation, it would cheerfully claim that it was going to find the first 10. Now, it looks like it's doing a lot better. And you know, Google said they were upgrading their stuff, so maybe they are. That's much more complicated. And there we are. The first 10 prime numbers are 2, 3, 5, 7. That's pretty awesome. The code looked like it was actually generating the first 10 prime numbers, but it really only got the prime numbers up to 10. And at this point, as I mentioned, I would go in here and fix the code because I know a little Python, but my students would just go back to Bard and say, this code is wrong, fix it. And that's another way to go, and really kind of educational. So you can write code with Bard, and you have to get good at arguing with it. It's like a really stupid assistant that only understands about half the instructions and does about half of that wrong. But that may save you time, especially if you're writing stuff like advertising copy that nobody's going to read carefully anyway. So anyway, there's various challenges here to try to get Python Bard to do things. which are pretty hard to do. And then I have a whole series of challenges I wrote for a previous DEF CON workshop, which are actually really good to get Bard to write these. And let me just show you one of them. For example, if you go down to, I think it's strings or network. Let me see. I think it might be this one. Yeah, this string processing. Yeah, here's one. You learn how to process strings in Python, where you can cut out pieces of strings, and then you learn how to connect to a server in Python. And you could do that, and then you start sending and getting, this is something you'll see in almost every CTF. The server says, what have you to say? And you can echo it back. Then the server says, your number is 90. You have to add 1 to it and send it back. This is something you'll see in almost every CTF. Write something that can automatically receive it. You can totally get Bard to do this. So here, you can just tell it to do this if you don't know any Python, and it will do it for you. The problem is, you have to be a little smarter about your instructions. So here, connect to this server on that port, send it the string goodbye. Well, by the way, I didn't even tell it to write Python code, but I think that's the default in Bard. Okay, there's code that will do it. Receives the message from the server, def main. Okay, there's a bunch of code. Use code with caution. Caution, it is to laugh. All right, so let's run this. By the way, I was really surprised to find out you can do port scans and stuff from inside Google Colab. I bet you won't be able to for much longer. I mean, everybody else that has online Python environments, they won't let you do things to other servers from it, but Google doesn't seem to have figured that out yet, although maybe after DEF CON. So anyway, it connects to the server, sends the message and receives the response, but it doesn't print out the response, so I don't get the flag. You have to tell it, print out the response, for example. But anyway, this whole bunch of Python challenges are perfectly fine machine learning challenges. Figure out how to do these puzzles without bothering to write the code. And so give some of that a shot. And then I'll talk about some other things. Or maybe I'll just do this right away. There's one other thing to mention, which is the theory behind all this, which I highly recommend. At the bottom of this page, I put a link to this article, a jargon-free explanation. This is extremely interesting. This Ars Technica model helped me understand this better than I ever had. There are several things required for these large language models to work. And one of them, the part I understood, is the part I did 35 years ago, where you have a bunch of neurons, another layer of neurons, and they mix the inputs. We've had that for a long time, but it didn't really accomplish anything by itself. What we didn't have when I did this was a way to encode language into numbers that worked. But what Google published in 2013, and what I just learned is something that genetic scientists knew earlier, my sister did for her PhD about 30 years ago, is a way to organize data this way. You have to take all the words and organize them so puppy and dogs are near each other and cat is over here, and the vector that takes you from dogs to puppy is like the vector that takes you from cat to kitten. So you can take dog plus puppy minus cat, and it will give you kitten. That's what you need. You need a representation of words that organizes them so the similar words are together, and words with relationships are related to each other the way they should be, and it turns out you can do that in a 300-dimensional space. You give each word a set of 300 numbers, and Google published the algorithm in 2013 to do this, to turn words to vectors called word2vec, that will turn them into these vectors, and now you just do math on the vectors, and you feed it in all your input words, which make a vector, and it just extends that vector to the next logical thing that you'd expect and creates stuff that sounds and looks pretty good. The problem is it doesn't have any sensory organs. It doesn't know there's a real world out there. It doesn't know what any of these words mean. So that's why it will just mix the truth and a lie in the same sentence. And it doesn't even know what's going on. You know, you have to understand, we've made a new tool to play with here, and it is just like, in some ways, these dark science fiction, where you've created this weird robot that doesn't have any conscience, doesn't even know what it's doing, doesn't understand that anything it does has real effect, but it looks like it's smart. And there was a very interesting article I read recently by an autistic person that said, the problem with autism is a lot of us are really smart, but we can't talk, so people think we're stupid and treat us like we're retarded, and you can't tell them, stop reading me the ABCs, I want to read Shakespeare. because they can't talk. And people confuse being unable to talk with being unable to think. And in AI models, they make the opposite mistake. They confuse being able to talk with being able to think. It looks like it understands you, like it's in love with you, like it's helping you with your problem, like it's sorry for your mistakes. And it's just repeating phrases it found on the internet with no clue what any of it means. It's fooling you. You have to understand the really intrinsic limitations of these things. But anyway, this explains it in great detail without any technical jargon. I found this extremely helpful to understand the stages of processing required to do this. But it really is fantastic and effective. So anyway, that's the LLM section of this. And I'm going to move on to writing our own stuff in Python after this. Let me stop this recording.